Welcome to PV Online Chemistry, and now we're going to take a look at a Charles Law problem. Charles Law deals only with volume and temperature changes of a gas. So this time we're going to be keeping the pressure constant. Francine has a sample of oxygen gas that occupies a volume of 627 milliliters at 298 Kelvin. That would be the first condition, so I'm going to identify this 627. That will be my V1 of the oxygen. The 298 Kelvin will be the T1. Now it's very important that you're in Kelvin. If instead you have a problem where the temperature is in Celsius, remember you're going to have to make that conversion to Kelvin. Now it says if the temperature increases, then what's going to happen to the volume? Now, volume and temperature are directly related, which means that as the temperature goes up, so will the volume. So knowing that before we even start, that should let us know whether or not we're doing the problem right. So their new temperature is going to be 308 Kelvin, and I want to know what is the new volume. So what is the new volume? Okay, now we have to use the appropriate equation to solve the problem. Since volume and temperature are directly proportional, they're going to be a ratio, one of these. But now you have to choose, is it this first one or the third one? And you'll notice that the volume and temperature are paired up here, and that's what we have to do. So we're going to use this first equation for the volume and temperature. Now we need to rearrange the equation so that we can solve for V2. That means we want to get V2 by itself, which means I'm going to have to multiply both sides by T2. By doing that, the T2 will cancel out here on the right-hand side. That's going to give me V1 T2 over T1. Once you have the equation set up, now it's just going to be basic math. We're going to go ahead and just put in our values. So V1 had a value of 627 milliliters, T1 was 298 Kelvin, T2 was 308 Kelvin, and now all we have to do is do our calculation. Now let's think about what unit will our answer be in. And notice that the Kelvin is in the denominator and the numerator. Those two are going to cancel out, which will leave only milliliters, which makes sense because we want our answer to be a volume. Finally, we just have to put the numbers in our calculator. Everything that's in the numerator we're going to multiply, and anything in the denominator we're going to divide. So we take it and we put it in our calculator, and I got 655 milliliters. And there you go. Good luck.